All right, so the next part of the practice exam or rather the bulk of the exam, deals with linked lists. Now on the practice exam, I like to do doubly linked lists, and on the regular exam, singly linked lists as the assumption. Although I think on the actual exam, I give you the option. Although why you'd want to have to deal with previouses, I don't know, but it may help you if you can't figure out the answer. All right, so I just remind you that we've got generics with nodes, we've got heads, we've got a tail, there's the size, right? They're doubly linked, and they're called next and prev. So we just write a bunch of instance methods, right? And so here's the big thing. In instance methods, right, you're inside the linked list class, which means you can have access to the nodes, which means you can use .next, you can use .previous, you can grab the head, you can grab the tail, right? And you can use the getNode method because that's private. All right, so, but if you've got a static method, you can't do that. So here we've got an instance method called deleteList, which removes all the items in the list, making it empty. This is actually a deceptively simple problem. It's only worth 3 points. Okay, and there's a reason it's deceptively simple, but let's go ahead and I'm going to go into the linked list class just for brevity's sake. Okay, so public void, and let's go ahead and enter distractions free mode, public void delete list. So how can I delete all the nodes in the list? Okay, a bunch of different ways actually. First way we can do that is by saying, well, it's by following the constructor for one, but let's go ahead and just show you a bunch of different ways. First, while list.size is, so while this dot size, so while this list, its size is greater than 0, we are going to this dot remove index 0. So while the list isn't, so while this list is not empty, method call expected. Method call expected. Oh, did I not actually put in a size method when I did this? That's very funny. Public int size return size. There we go. All right. So while size is greater than 0, remove the size of the remove index 0, right? And this makes it fairly easy, right? You just remove index 0, and removing a single item is a constant time operation. So if you have n items, this will take O of n time, right? Do I ask you about that? Do I ask you how long that's going to take? No, I do not, but it's good to be able to figure that out. So are there other ways to do this? Oh, and I mentioned that the tail is optional. So another valid answer would be this two-liner. Head is equal to null, so remove the head. Tail is equal to null if we are keeping track of the tail, and this dot size, or rather, and then size is equal to 0. And this will work because the garbage collector will clean up everything else. That's all we need to do for that one. All right, so write an instance method called count. This is one of the new ones I wrote, or that I got, that I was debating whether or not which exam to put it on. Should it go on the practice or the real exam? Right, let's write a instance method called count. Count iterates over a linked list and returns the number of time an item occurs in a list. So again, so we're going to count how many times this occurs inside of our list. So we'll go ahead and say, we'll go ahead and call int count is equal to 0, right? We've seen it 0 times so far at the beginning, and we are going to return 0 at the end. So not 0, but the amount of times we see it, so not 0, count, right? And so now we're going to use the iteration method that we've been using before. So while current. So we're going to create a node e current. It's equal to the head of the list. And while current is not null, we're going to do the following. Current dot item dot equals item. So we're going to go through each item in the list, and if it's equal to that item, then we're going to increase our count. Right? And otherwise we don't increase our count. And then we need to move on to the next item. Current is equal to current dot next, right? This iterative method of going through a list is very important to know. So start with a count is equal to 0. While we start at our head, while it's not null, we check the item. We check the item inside of current and check if it's equal to the item. Another way that you might have rewrote this is item dot equals current dot item, right? And if it is, count plus plus, and then we say current is equal to current dot next, which stores the value of the next node in current, so we advance to the next node. And if that one is null, then we are done. Okay. And that's a fairly easy 10 points. Oh, what is the time complexity of this algorithm? So we go through each list we go through each node exactly once. Each item in the list gets checked exactly once. So it's O of n, right? The vast majorities will be either constant, O of n, or O of n squared. Okay. So this one's interesting. I like this one a whole lot because it comes up later. Now notice this one's a static method, meaning we don't get to deal with nodes at all. So write a static method that takes in two sorted linked lists of integers and merges them into one sorted linked list and returns them. So this is a static method outside of linked list. You cannot access the nodes. You are allowed to remove nodes from list A and list B. So okay, let's go ahead and do this. And this one I'm going to put in the linked list class anyway. And it's in the doubly linked list. So I'm just simply going to change this to, let's see, it says this. So, right, doubly linked list, right, takes in a doubly linked list of integers, doubly linked list over here, doubly linked list over here. And then, boom. All right. So you can just use linked list on your exam, the doubly linked list of integer out is equal to new, and I'm just setting this up before I repeat what we're doing here. And out. Okay, so in this one, what are we doing here? We are taking in a method that takes in two sorted linked lists of integers and merges them into one sorted linked list and returns it. So we're taking two lists, we're combining the elements into a single sorted list. Right? So let's go through an example of what that might look like. We've got list A, 1, 4, 5. We've got list B, 2, 3, and 7. Right? And so our output would be 1, 2, 3, 4, 5, 7. Right? That's our output. Okay? All right, so some of you might go something like, so some of those of you who've done some research might decide to do something like this, right? You're like, aha, those are comparable. So those of you who have like gotten to really know the collection package by doing some research and stuff, you might go like this. Oh, out.add all, right? Which is a method if we're actually dealing with the linked list class. Right, it actually exists in the list interface, but I just don't have it implemented here. So this is a method that actually exists. Add all from A, out dot add all from list B. And then since this is a collection, I can do collection dot sort or collections dot sort out, and that will be that, right? So that's if you really know the things in there, and that would take, well, what is the sorting algorithm used? How long does that take? How long do these things take? Well, this takes O of n, and assuming that these list A and list B are the same size, by the way. If they're not the same size, it kind of changes our answer, but for right now, we're going to assume they're the same size. It would take O of n log n time total. But let's assume that we don't know that, and we actually, because I'm assuming you don't. This one, we need to basically be able to put these things together and then, well, let's see. Your first idea might be what we just did there, which is put these things together, 1, 4, 5, 2, 3, 7, and then try sorting them. And then try sorting that so we can get 1, 2, so we can get our answer. Or you might go, well, we did that bubble sort thing, I can just re-implement bubble sort there, but that would take some time, and that's kind of hazardous. But notice that I'm not giving you two lists, and I'm asking you to merge them and produce a sorted list. I'm telling you to do two sorted lists, right? We've got two sorted linked lists here. So that's very important, because if we think about this, actually, these things are sorted pretty much relative to each other. So we can do something like this. I can look at this first item, right? At the first item of each of these things and go, which one's smaller? Which one, that would be the one that goes first. 1 is the smaller one, so we'll go ahead and remove that. Okay? And then we've got, then we just keep doing. Which one of these is smaller? 2 is the smaller, so we'll just remove that and tack it onto the end of our answer. 3 is the smaller, so we'll go ahead and tack it onto the end of the answer. Then 4 is the smaller, right? And then 5 is smaller than 7, so that will get removed and tacked onto the end. And then it's empty, so we should probably figure out what to do there. Then we'll take everything from A and add on, and everything from B and add it to the end. So what will this do? So essentially what this means is that all we have to do is just compare the beginnings of both of the things in this list. Let's look at another example, right? One, 4, 5, 2, 3, 7. So let's go with 1, 3, 4. Okay, so we look at the index 0 of both the lists. Which one is smaller? We remove the smaller one. We look at the index 0 of both the lists. Which one is smaller? We remove the smaller one. And so on and so forth until we get to the end. Okay, so while list A dot size is less than, well, list A dot size is greater than 0, and list B dot size is greater than 0, we're going to do the following. If list A dot get the item at index 0. Oh, again, I didn't get the program I get into the doubly linked list. All right, so public get int index. That's easy enough. Return this dot get node index dot item. Right, technically you should check if it's a valid index first, but Tempest Fusion. So if list dot get incompatible types. Oh, so if list A is greater than, if the item at the beginning of list A is greater than the item at the beginning of list B, what should I do? Out.add list A dot get 0, and then we'll remove it from list A. List A dot remove index 0. Otherwise, we will go ahead and do the opposite. Otherwise, B is equal to, or is bigger or equal to, so we'll just say, okay, we'll remove the item from list B. And we'll do that until one of these runs out of items. Okay, once one of them is out of items, what we'll do is that we'll go through list A, while list A dot size is not equal to 0. Out dot add list A dot remove 0. And I'm just doing that in one line now, right? We're going to remove the item from index 0 and add it onto the end of our list. And then we do it for list B. Now the reason is that we don't know which one of these, so one of these ran out of items first. We don't know which one. So rather than trying to figure out which one, we're just simply going to go through both of them and remove items until they're out of items. And so that will be the pattern that I went through up there.